So this slide is basically about a summarizer putting the reflections in the x-axis and the amplitude changes together in one graph. So essentially what we have to do is we first need to take a look at what function we're working with. And because we're working with sine in the first problem, we know that sine's basic graph starts 0, 90, 180, 270, 360, and sine starts at 0, goes up to 1, then 0, then -1, then 0. That's our basic graph. So as we're looking at our basic graph, we know that this is going to make a sideways S. All right. But the thing is, we have two things going on here. We've got an amplitude change. That's the 3. That's the amplitude, which means it's going to stretch 3 times as high. 3 times as high. And it also has a negative, and the negative tells me that I have a reflection in the x-axis. Keep in mind that those two things are separate. So this tells me it's a reflection, just the negative part. And then the amplitude is 3. Amplitudes are always positive. So the amplitude is 3. So what I need to do is I need to look at the fact that for my graph, a regular sine graph is going to start at 0, go to 1, go to 0, go to -1, go to 0. Here's where my 1 will be. Here's where my -1 will be. And that's basic sine. Okay? Then if I put in a multiplier of 3 and a reflection to find this MASH, all I need to do is multiply these outcomes by -3. So this would be 0, -3, 0, +3, and 0. All right, this is going to be both transformations together. All right, taking that negative and that 3 and multiplying it by these normal outcomes. So that means I would have to start at 0 like this one, but then go down to -3. So if I'm at -1 here, let's go -2 here. Let's do -3 here. And then we have to go 1 and then 2 and then +3 up here. And here is our down to -3, then to 0, then to +3, then to 0. So it's instead of it starting at 0 and going up, it's going to start at 0, go down. That's that reflection. And the stretch is 3 times as big. And then 0, and then stretch up to 3, and then back to 0. So this one is y equals -3 sine theta. Okay, this is what my graph would look like. So reflection means I got to start and go down first, and my amplitude change of 3 means it's going to stretch 3 times the size instead of just a regular 1 time. It'll be 3 times the size, but moving in the opposite direction. For cosine, a regular cosine, 0, 90, 180, 270, 360, starts at 1, 0, -1, 0, 1. And again, we get those from the unit circle. So I'm going 1, we'll do -1 here. 1, 0, -1, 0, 1. There's my basic cosine. U-shape. And because of this guy, this is what I have. I have a reflection in the x-axis. That negative represents a reflection in the x-axis. And the 2 is the amplitude. 2 is the amplitude. And that tells me that I'm going to stretch twice as high. So to get both, all I would have to do for both is multiply these normal outcomes by -2. They're both multipliers. So this would be a -2, 0, 2, 0, -2. Again, multiplying each of these by -2 gives us these outcomes. So I have to go down to -2 and up to 2 to get that stretch. And instead of starting at 1, I'm starting at the bottom at -2, 0, +2, 0, -2. And instead of it looking like a U, this is going to look like a mountain shape. All right, keep in mind, it's very curvy. You shouldn't have any straight lines. There should be no points. It should be very curvy. Right, so practice doing that. You can trace it on your screen with your finger and then try and replicate that. And this next one, number 3, it's 1/4 sine theta. So we're back at sine. The interesting thing about sine, I'm not going to keep writing your sine values. You need to make sure that you're getting them from the unit circle. But this does not have a reflection. This is just your amplitude. And this amplitude is a shrink because it is between 0 and 1, which means that we're going to make it smaller. So regular sine, hopefully you're getting it, 0, 1, 0, -1, 0. Here's your basic sine. Sine that's positive starts at 0, moves up. And then this is a positive sign, but 1/4 of the size. So instead of it starting at 0 and going up all the way to 1, we're only going 1/4 of the way. That's like right here. It's still a curve, though. It's just not as curvy. So look, it's still an S shape, but it's very flat. It's almost linear. So the lower the value, or the closer you are to 0, the flatter it will look. Whereas the higher the amplitude value, the stretch factor will increase, and the taller it will look. Taller, smaller. And here's number 4, our last one. Just trying to make sure we get the hang of this thing. This is a cosine. So for cosine, you know that we're going to use these values on the unit circle, the x values, which are start at 1, go to -1, 1, 0, -1, 0, 1. That's our U shape. That's our normal. That's cosine, regular cosine theta. But look at what's going on here. We've got another reflection. This is a reflection in the x-axis, which means that we are going to, instead of starting up top, we're going to start down bottom. But there's also an amplitude change, and our amplitude is 0.8. Now, when our amplitude is 0.8, that means it's 0.8 of the way to 1. So it's about 80% to the 1. But because we're reflecting, it's going to be starting down here at -0.8. All right. And then we're going to go to 0, +0.8, then go to 0, and then -0.8. So this one is going to look like a mountain again. But a little bit flatter than this one. This one went huge. That was twice as high. This isn't quite 1. This is about 80%. All right. So you can get reflections in the x-axis for both sine and cosine. This is what it does. It literally flips it from the top to the bottom. Amplitude changes stretch. If it's higher than 1, it's going to stretch it nice and tall. If it's between 0 and 1, here's a fraction example, here's a decimal example, it's going to shrink it smaller and flatten it out some. Okay, so the green is definitely flatter than the blue. Although 80% compared to 100%, it's not that flat. But here we have 25% compared to 100%. So this is a lot flatter. All right, so that's how you put these together. We have one more concept and we're done for this week.